Okay, good evening, everyone. So thank you for joining us for our 12th lecture for this year in the LaSalle Sustainability Lecture Series. So the Sustainability Lecture Series is an initiative of De La Salle University in cooperation with the International Association of LaSalle Universities. These monthly talks are meant to engage the global LaSallian community in responding to the UN Sustainable Development Goals and Pope Francis Laudato Si encyclicals. To start us off, I would like to call on the Vice Chancellor of Research and Innovation of De La Salle University, Manila, Professor Raymond Tan.
Thank you very much, Dr. Kay. Good evening or good morning, depending on which part of the planet you're in. It's my pleasure to open this final installment of the 2021 DLSU IALU Sustainability Lecture Series. And it's the last of the series, but certainly not the least. In fact, I'm especially excited about this event tonight or today. This is the product of cooperation, which we can trace back to 2016, almost 6 years ago, in fact, when the main speaker, Professor Dr. Michael Promentilla, who's actually in the UK right now, met his British counterpart, Dr. Devendra Saroj, in a British government-funded research networking activity that we hosted. And the idea back then, which seemed it seemed a bit strange to us, to be perfectly frank, back then, that money would be spent, British taxpayers' money would be spent just for essentially for people to get to know each other, almost like a social event with research dimensions. But in fact, the success of their partnership illustrates how the grassroots engagement of like-minded colleagues working on a common global scientific sustainability problem can really go a long way. And I'm happy to note that this team has grown and involves graduate students, two of whom are with us tonight, one of whom is completing her PhD in the UK under Dr. Saroj's supervision, another one doing a master's degree under Professor Promentilla's supervision. What we've also done is, by we, I actually mean the research team, and we should not take too much credit for what they've done, is to link up with a LaSallian partner, De La Salle Araneta University, represented here by Ms. Apple Suplido, because the intent of the project had to do with sustainable farming. I won't preempt the speaker, but the idea was there's a sustainability aspect to growing crops to meet human food requirements. And what was needed was a partner with actual farm facilities. And this is perfect to link up with De La Salle Araneta University, just a few kilometers to the north of the capital here in Metro Manila. And this was done, if I'm not mistaken, it was done in 2019. And everything came together just 2 months before the pandemic. And I remember the occasion quite vividly. Professor Promentilla and Dr. Devendra and the entire team received what is known as the Newton Prize, a bit of a misnomer. It's not really a cash prize. It's actually a research grant to the tune of, if I'm not mistaken, something like 14 or 15 million pesos to push the project forward and drive the collaboration forward. And of course, unfortunately, the pandemic has slowed down a lot of the planned activities, but you can see that with Professor Promentilla being in the UK, they actually proceeded with the work to the best of their abilities. And likewise, there's actually a PhD student making good progress in the UK, also on a related topic. So this lecture tonight or today is about, deals with food security. It deals with water pollution, both of which are represented in the United Nations Sustainable Development Goals. And I'm glad to say, first of all, that this is a great way to end the series for 2021. We have a very strong lecture with multiple panel members giving their thoughts and their insights based on their contributions. And I'd also like to say that, of course, we look forward to more of these talks perhaps in a modified format in 2022. With that, I just want to say I wish all the participants from different parts of the world an engaging discussion tonight or today. Thanks very much.
Thank you very much, Professor Tan. Now I'd like to call the Director of the Center for Engineering and Sustainable Development Research to introduce our speakers for tonight.
Okay. Good evening, everyone, and good morning in some other parts of the world, or afternoon. Of course, let me just also greet Brother Joe Schreiter here, FSC, Brother Ray Suplido, FSC. I hope Chancellor Emeritus Dr. Carmelita Crebenco is with us, and all the brothers, all the participants, guests here. We are actually honored to have four these are distinguished also speakers, to actually put together in this final episode of our year-long Lasallian Sustainability Lecture Series. And the Center for Engineering and Sustainable Development Research was established back in 2003, primarily to undertake sustainability-related studies, and those long, over 15 years now, we have over 6,000 perhaps Scopus indexed articles that are related to sustainability as a product of many of our collaborative, researches, not only within the Philippines but of course around the world. And again, this evening, I'm privileged to introduce the first speaker. He's a full professor from the Chemical Engineering Department of De La Salle University, Manila, received his PhD in Socio-Environmental Engineering from Hokkaido University in Japan. His research interests include application of decision modeling and risk analysis to environmental and energy systems, as well as the design and characterization of sustainable engineering materials. Ladies and gentlemen, he's Professor Dr. Michael Angelo B. Pimentel. I would like to introduce the other speakers as well who will speak this evening. Currently, the OIC Executive Director of the De La Salle Araneta University, AGSI, and Assistant Professor at the same university, a graduate of the University of the Philippines, Los Baños, for both her BS Agriculture and a master's degree in Social Science, Maria Eda Apple A. Suplido. She will be joined also by an associate professor from the Chemical Engineering Department of De La Salle University, Manila, received his PhD in Environmental Engineering and Biotechnology from Yonggi University in Korea. His research interests focus on membrane technology application, wastewater treatment, biological carbon capture, and material development. He is Dr. Arnel B. Beltran. And finally, the Vice President, Executive Director of SCPW and the RAMCAR NGO Communication, Education, Participation, and Awareness focal point for the Philippines. She leads the training and communication work package of the project, including stakeholder engagement with communities, policy institutions, local government units, and NGOs for Project Next Series, Ms. Ami Leciones. Ladies and gentlemen, to present the nutrient recycling toward a green circular bioeconomy, Professor Michael Pimentel and his team. Mike.
Thank you, Professor Kulaba, for the very informative introduction. And on behalf of the team, I would like to thank the organizer of this Sustainability Lecture Series for giving us this platform to share our vision, share our recent findings out of this Newton Prize project. So please allow me to share my screen. Can you see my screen right now?
Yes.
Okay, so I'm just so this was basically a front act of this how would you say 2 hour research dissemination session, wherein of course if you remember a concert, a front act would be just be preparing for the main event, and the main events actually are my team from the Salicneta, the Lasal Araneta University, and from the SCPW, from the Society for the Conservation of Protection of Wetland, and of course from the Lasal University, who is actually the one who made this possible, this Newton Prize. So I'm just here as a, I would say, a front act artist or scientist, just to give you the big picture or the context of what we are doing and what we envision of this project in the near future, and of course, these are our long-term plans. So as you can see, around we experienced COVID, and this gave us opportunity to rethink, to imagine our current systems. And in this case, I would like to emphasize on the sustainability of the agri-food system, not only here in the Philippines, but globally. And just to highlight the challenges that we are encountering. In 2050, we have to fill at least additional 2 billion of individuals, and this, of course, would require an increased food production that would increase the pressure on our environment. And I don't need to elaborate on the potential impact of food and agriculture to the environment, as you can see from this slide, which is beautifully summarized in our world in data. The impact of the food and agriculture to the environment, not only on the pressure on resource scarcity, the biodiversity, and even eutrophication. And you can see the interrelation of the issues even in energy, water, and food. So we have to think in systems, wherein we look at, for example, agri-food system as an interrelated issues that would need to be addressed, not only on addressing the hunger of the society, but also on how it will affect, of course, the nutrition and health, and its impact on the climate change, and how the climate change also, or the environment, impacted this food system. And in this case, just to give you an example, how even changing our behavior as a consumer by consuming types of food would really affect how we could address the impact of climate change, and even the issue on global health. As you can see from this, the choice, for example, of some kind of diet like the planetary health diet or a flexitarian diet could reduce this, what you call health costs, and even the climate change costs when you compare to what we are having right now, which is possibly a high carbohydrate, high salt, and so on. And the topic of my talk is about the future. What could be the preferred future of our agri-food system in a green biosecure economy? Can you think of ideas on how we can change our agri-food system? If it appears to be ridiculous, don't worry. It's a hint that it could be a useful idea. The next question is, what are these catchwords? Because these catchwords are now being popularized, being marketed, because this is one pathway to sustainability. Can you imagine a sustainable future wherein we have this vibrant bioeconomy? We have this actually already pushing, even here in the EU and UK, this concept of circular economy and green economy. So when you look at bioeconomy, you are looking at the production of these value-added products from these renewable biological resources. So we are not only looking the source of food from these biological resources, but as well other important commodity wherein our feedstock would be these renewable biological resources. And for this reason, we have to really understand how we can grow these biological resources. And this is one proposal on how we can imagine the cities of the future. This was popularized by Ellen MacArthur Foundation, who is a very one of the pioneers, prominent in pushing circular economy. In this case, they are imagining that the future of cities should encourage this kind of locally grown food, wherein we can restore regeneratively the biosphere. We should design and market healthier food products. As I have mentioned to you, maybe shifting the dietary pattern from what we have right now to flexitarian or even to more plant-based diet could address several issues linking food security, water security, and even our issue we are facing right now on attributed to climate change. And of course, we have to make the most of food, wherein the products from this system can become a feedstock to this bioeconomy. And I can also imagine what I refer to as the data economy, or what we call the digital revolution, wherein this nexus of data would be very important, not only looking at the health issues, but also the consumer values, and of course, linking this to the food supply and distribution, wherein sustainability is one of the main indicators or drivers in order to push this next generation of technology, wherein it could then enable this what you call a sustainable agri-food system. And this is where our project comes in. Looking at this bigger picture, what we intend to have in Project Necessities is actually a research program which we conceptualize at our research center in Gokongwei College of Engineering, which actually Professor Kulaba is the director of this center. We envision that this research program would somehow address the issues that link this water, energy, and nutrient. This nutrient actually is the important component in the agri-food systems. And of course, Professor Tan gives us an overview of how it was started. It's actually through partnership with our UK counterpart from University of Zurich, Dr. Saraj. And now we are extending this partnership to our sister university, the La Salle Araneta University, and to a civil society or non-government organization like SCPW. I think this is one of the first, initiatives that consider this cross-sectoral collaboration in order to realize the vision for the next cities. And of course, because we know that the large proportion of food is actually being processed and consumed in cities, and take note that we are still using this paradigm of linear economy, even in this kind of system. As you can see, less than 2%, in fact, of the valuable nutrients are being recycled back in the cities, considering the resources involved in producing this food for us, like the fresh water, the chemical input, the energy needed, and of course, the land resource, which of course provided by the nutrients from the soil. And I would like to emphasize from our perspective, because we cannot tackle everything, but now we focus on one important chemical input. This is fertilizer. And the question is, will the mineral phosphorus fertilizer production can keep up with the demand, consider of our growing population? You may be wondering why we should be particular or be concerned about phosphorus. Because phosphorus is actually no, is an element critical for life. You cannot find any substitute for phosphorus, unlike, for example, for fossil fuel base that provides us energy. You can find renewable energies, and even nuclear energy could be a very good substitute. But for nutrients to grow crops, to grow our food, we need phosphorus. And you may be wondering, but I think phosphorus is everywhere. Yeah. When we grow our crops, no, to a level that will satisfy the demand of our population right now, in order to have this desired crop yield, we need to supplement phosphorus to our soil, to our land. And this phosphorus came from a non-renewable resources. We are mining this phosphorus actually in a form of phosphate rock. And of course, there are some researchers that include us that think that global phosphorus security is in fact an emerging theme that we should look at, because it linked to the security of the future food, even energy and water security for a growing population. And just like climate change, there is no one quick solution for this kind of problem. It requires a portfolio solution. It requires integration of possible approaches. It requires systemic approach in order to address this important issue. And in this case, we are looking at the possibility of reusing human excreta. Why? Because we think that this will play an important role, especially if we look at the interlinked issues of water security and food security. As seen from this slide, you can see that about 20% is actually being used only for growing crops out of this phosphate that being mined in, how you say, limited geographical sources. And that entails, of course, another geopolitical risk, because, for example, the sources of this phosphate is being controlled by very few countries like Morocco, US, and China. And this can be another tool for trade war in the future. So that's one way to look at it. Another one is, of course, if you look at phosphorus, from the point of view of the water or wastewater sector, it is being considered as a pollutant. While, of course, it's a valuable nutrient resource from the agriculture sector, the mismanagement of this phosphorus resource, in fact, is a problem, not only to the agriculture sector, but also to the environment, particularly in terms of nutrient pollution to the water bodies. And this is what we would like to emphasize now at Necessities, is how in the human system, human cycle, how we can recover this phosphorus. And that, of course, if you would like it to be context specific, this now translates to its impact on the problem of sanitation care in the Philippines. And I don't need to enumerate all of these facts and figures, but what are we looking at right now is, in fact, we still have a long way to go to achieve the target for SDG number 6. And what is the problem of our current sanitation system? I don't need to elaborate on these issues. I believe many of you already are aware of the problem. For example, even we do have this centralized septage or sewage treatment plant, we have problem as well on the on-site sanitation systems, such as the septic tank. And these are also sources of contamination of our groundwater and even our surface water. And we think that this nutrient pollution can be addressed by looking at the problem. So right now you are hearing our way of informing the general public. So we use this to show the farmers the impact of this septic tank, mismanagement septic tank. So what if we change the paradigm from a linear to a resource-oriented system, sanitation system? What if we can recover the nutrients from this septic tank instead of this as a potential contaminant to our groundwater, to our surface water? What if we can recover this? And of course, recover these nutrients in a form of fertilizer, we can grow our food locally. So these are the things that maybe has a potential in the future. And this is what all about the Necessities project is, which is now being funded by Newton Price. To know more about this project, you can look at our social media pages, like from Facebook, from Twitter, and even we have our own website. And this is through the help of SCPW, who are helping us in disseminating our research and mainstreaming our science to the general public. Later, they will present on how we can engage effectively the stakeholders, because as I have mentioned to you, we have to think in systems. We don't need just to focus on the technology itself, but of course, the other aspects when we try to push this kind of system. And of course, we have this we call 4 work packages. And the next lecture, the talk will be discussed by my teammates, who will discuss some of the findings from these different work packages. So we had a very good partnership from De La Salle Araneta University, from Salicneta team, being led by Apple Suplido. And I would like to take this opportunity as well to congratulate the team, Salicneta team, because recently they won the Philippine Water Challenge. This is a very prestigious event as far as I'm concerned, because this is just a testimony of the potential of this kind of project through this kind of partnership as well. And of course, we have several engagement with the farmers through the help of the SCPW, which will be explained later by Ms. Ami. So these things are actually just the start of what we are envisioning for a sustainable agri-food systems. And of course, why we are so passionate about it, because if we will have phosphorus scarcity, increasing prices of fertilizer, this non-renewable resource, the most affected is actually our marginalized sector, the farmers and those poor households. This is what we already experienced even in the issue of climate change. So we should try to engage these sectors, even we are still developing the technology. So just to give you an overview of the technology, we developed a simple process. Of course, from the chemical engineering point of view, it requires 2 chemical process, the hydrolysis and precipitation, in order to recover these nutrients from the septic tank or from the septage. And this will be discussed further by my colleague, Dr. Arnel Bertrand. He's working with, of course, the lead researcher for this work package 2, who is Dr. Eileen Orbisido. And of course, hopefully, this recovered phosphorus in the form of fertilizer can be used to grow crops. And this is the reason why we partnered with Salicneta Farm, the Salicneta team, to test whether we can grow these crops. And Apple Suplido will of course discuss this further. So this is our dream, to understand the value chain from the septic tank, from the start of the production of this, how you'd say, potentially nutrient-rich feedstock until to the application in such a way we can help farmers, and hopefully it can create new business models in such a way we can have a green sanitation system in the future that can be part of the bioeconomy. And this is how we envision this system wherein, for our part, of course, we try to recover the nutrients, which, if not recovered, it could create environmental impact to the water bodies. And hopefully this green fertilizer could alleviate the problem on the phosphorus scarcity somehow. And that would also help in the pushing this concept of bioeconomy. Because we have to remember, these biological resources will require nutrients, whether it is for food or for high value commodity, even for biofuels. You still need to utilize these important nutrients. And the takeaway mission that I would like to give to you, a food for thought, is it's already here, this future. It's just not evenly distributed. Why? These are signals that shows that it is possible to have this preferred future. Just look at these signals like what we are doing right now. In developed countries like Canada and UK, they are looking at the Ustarak process to recover nutrients in order to produce this high-value fertilizer like struvite. There are also interconnections between this STP transforming to as a resource recovery facility, and of course the sustainable agriculture, and in the cities as regard to food consumption. So these are happening actually already, only of course in some isolated areas. And another interesting signals for the future is how we can transform or nudge the behavior of consumers. And this is, for me, I find it funny, interesting, because they use this as a way for a cryptocurrency to work from this what you call eco toilet. And of course, you may already know this one, that Bill Gates, the Gates Foundation, are very ambitious in pushing this future of sanitation, and they are funding a lot of what you call high-end toilets. So the takeaway is the future seems to be bleak at this time, but we are optimistic. It is possible to look at this septage or sewage or sludge as a potential resource. It's just that we need to understand these several drivers, not only the push from the present, you could say we can have this technology push, but also we have to address the legacy of the past, like our current infrastructure that could be a technology lock-in. But keep in mind, with the pull of the future on how we envision what a sanitation should be, could help us to really plan and come up with a sustainable strategies for this agri-food system. So agri-food system, of course, is the bigger picture. But if I look at this, I think I would say it's pretty much connected to resource-oriented sanitation systems, which I refer to as ROSAS. This picture is a symbol of the change of paradigm, the change of mental image from a yucky sludge to a beautiful rose. This photo was taken here at Guilford when I stroll around at Stokes Park. So it just reminds me that this powerful image, this powerful metaphor of process. That's it, and I hope I was able to inspire you on what could be our preferred future. And the next lecture will give you the details of the topic of Necessities. Thanks everyone for listening.
Thank you, Mike. May I know who's the next speaker?
I think Dr. Beltran is the next speaker.
All right, thank you.
Okay, hello everyone. So good morning, good evening, good afternoon to anyone in the world. So let me share my screen for today's lecture series. So can you see my screen now?
Yes.
Okay. So again, hello, I'm Arnel Beltran from the Chemical Engineering Department, and I will be presenting our work on work package 2, which is on the pilot scale or small scale production of phosphorus fertilizer from the septage sewage waste for farm crop application. The farm crop application will be discussed by my colleague, Ms. Apple, later in this after my presentation. Okay, so this is a collaboration between the University of Surrey and Nottingham with Araneta, De La Salle Araneta University through Salecneta Farm and SCPW with De La Salle University. Okay, so as we all know, the phosphorus cycle is from the main source is the phosphorus mine, where this phosphorus mine is transformed into a fertilizer and was utilized for agricultural application. And this agricultural application is usually used for human consumption and animal consumption. And also the animal consumption or the animal produce is also part of the human consumption. And typically, the waste generated from human consumption is translated to waste or wastewater treatment, which this include the septage and the sewage and other industrial systems. However, the phosphorus typically are being transported to the bodies of water. So this is a very famous image from Boracay, where you can see the algal bloom, which is caused by eutrophication, which is an indicator of a large amount of nutrient is present in the bodies of water. So with this Next Cities project, we are aiming to utilize the network from the sewage septage or manure in the wastewater treatment instead of deploying it to the bodies of water we want it to be a source for phosphorus and reduce the dependency on the phosphorus mine. And this resource from the wastewater could be transported to the fertilizer manufacturing plant or directly to the agricultural application. And the typical pathway for your sewage sludge and septage sludge and animal manure is through composting. This is a very known application of this material. However, the challenge with composting is the time that it required for this waste to be converted into compost or a fertilizer and the health concern. Another approach is through the struvite fertilizer production. This is a known known technology already, but the application is a little bit not being utilized because of the rich phosphorus mine that we have. However, mine are not sustainable, not non-renewable source of phosphorus, and we can utilize this waste as a renewable source for phosphorus for fertilizer production. So typically, how is struvite formed? Basically, this is with amount combination of your magnesium, ammonium, and phosphorus. You can have this form as a powder. And typically, this is a problem in wastewater industry because it could build up in the pipelines of a sewage system. So you can see here the pipe that has a struvite formation. And another one is not just in animal, but it could be produced or generated in the kidney as a kidney stone in animals and human. In wastewater treatment or sewage system, so with the correct formulation and treatment, we can generate your struvite, which is the magnesium ammonium phosphate hexahydrate formulation from septage or a sewage system. But prior to the formation in terms of precipitation, this should be liberated the phosphate presence in your bioavailable phosphate in terms of the precipitation. And this struvite could be utilized as a phosphorus and a nitrogen source, and also the microminerals, which is magnesium, for fertilizer or plant production. So as mentioned by Dr. Promentilla, our project, which is the initial project is the Project Next City, which is funded by DOST and Newton Fund RCUK last 2017, and the continuation in the Newton Prize, which is a award given by the Newton Fund and the British Council. We generate this new technology or utilize this technology in the farm application. The first one is on the laboratory or systems approach, and the Newton Prize is on the actual application of the technology. So basically, we employ a struvite reactor. So we have this fabricated and deployed in Salicneta farm with this reactor. This is a pilot scale or a small scale reactor for struvite formation, where the hydrolysis and precipitation could be performed in the reactor. However, you can segregate the hydrolysis and the precipitation reactor, but due to economics, we can have it generated in a single reactor. So it was deployed in Salicneta farm so that once we produce, it could be tested for farm application, where later Miss Apple will provide it. So we installed it in some secured area in Salicneta farm, and our team able to utilize this one and produce and utilize the septage available in Salicneta farm. So initially, we utilize the septage that collected throughout Salicneta, where this process is been done by our team through manual or by the aid of pump in collecting the sludge. However, the amount of the sludge or septage that we collected is a little bit short in terms of the requirements for the fertilizer application. So we employed the help of a wastewater treatment facility or a septage treatment facility to provide us additional raw materials for the production. As shown already by Dr. Promentilla, the hydrolysis process, and I call this one phosphorus fertilizer production because the challenge of identifying the material to be a struvite is difficult as of now because we have multiple component presets in a septage system. So typically, we have the septage, mostly the solid, where most of the phosphorus are present, is poured in the reactor, and we hydrolyze it with an acid. So in this experiment, we use hydrochloric acid at this condition. So the mixing or the hydrolysis happens for 1 to 2 hours, which is this one is already at optimal condition where all the phosphorus will be released in the supernatant. Then we have a 3-day settling. So meaning we remove the reactor, we remove the materials from the reactor and do another batch and wait for 3-day settling. And we collect the supernatant and put it again in the reactor. Sorry for that one. For the reactor, where this will be treated with the required chemicals for the formation of formation of your struvite. So upon the precipitation and drying, we were able to produce the struvite that we need. And the wastewater generated is being studied also if it could be deployed or utilized in the process. Sorry for that one. Sorry for that one. I'll just need. Sorry for that one. Basically, this is the production team in Salek Neta Farm where they test the reactor and produce the struvite that we need for the plant. So these are the summary of the number of batches and runs that we conducted and the pH range and the precipitation value that we obtained from the production. So we have 34 hydrolysis run and 24 runs for the fertilizer production with a total volume of 2,000 and 3,000 with hydrolysis and fertilizer production. And this is the range of precipitate that we obtain for every batch. The summary per batch is we utilize a 100-liter reactor, but usually we run it at 62 to 100 liters. And this is the total production that was conducted in Salek Neta, where the total rate of production is at 2.92 grams per liter of precipitate, which is what we call the phosphorus fertilizer. And based on the characterization of the material, the content of the phosphorus, and it has the amount of nitrogen and phosphorus. However, this should be verified. So we're still verifying if this is in a struvite form or in other form that might be considered if it is available for the plant to be utilized. Also, there are a lot of metals that are present, but these are on micro level. And this one is the SEM images of the different batches of the phosphorus fertilizer that we produce. So the question is the phosphorus fertilizer that was produced safe to be utilized for plant or crop production? So basically, we evaluate the microbial analysis and the toxic metal content of the phosphorus, and based on the regulatory requirements, the value is still below the limit that the standard from FPA standard. Okay, so meaning the fertilizer that we produce from the struvite reactor or from the septage resources is safe to be used. And we also do a short or a small cost analysis. And the challenge here is that it's a little bit expensive compared to the commercially available, because this is still at a pilot plant scale level. However, if we were able to improve the raw materials requirement in terms of the hydrolysis, because the amount of acid needed for the production, or the cost is mostly in the hydrolysis of the system. So further improvement in this aspect of the plant is necessary. And also, based on our initial calculation, a payback period of 4 years is calculated at a return of investment of 23.88%. This is based on 480,000 kilograms of product to be produced and 160,000 cubic meter of septage to be treated. Okay, so technically, if we were able to treat our septage and transform the phosphorus present there into a fertilizer, the environmental impact of this phosphorus will be lessened. However, based from our study, we need to further improve the system in terms of the optimization for the plant to reduce the cost, improvement in the precipitation process, utilization of other raw materials, as it could be mixed with animal manure. Actually, we have already run on pig manure in Salicneta, and it will be discussed in other forum. And as I mentioned, the reduction on the hydrolysis cost. The management of waste is still necessary because actually we produce a sludge with low content of phosphorus and the wastewater, which is the problem is that it has a high pH level. But with pH adjustment, this could be directly disposed through the environment, but we need to check the quality first in terms of other pollutant. Okay, so these are the member of the team from De La Salle Araneta, the SCPW, and from University of Surrey and Nottingham. So thank you, everyone. So you can contact me through my email, or you can check our website and Facebook page for any question or clarification.
Okay, thank you very much for that, Dr. Beltran. So we'll get to the questions later once everyone is done with their lecture. I suppose the next speaker would be Ms. Apple. Is that correct?
Yes, good evening. So, good evening, everyone from the Philippines, and good day to all. So, I'm here to present the accomplishments and initial results under Work Package 3 of Project Necessities. So, I'm Maria Eda Apple Suplito, the team leader from De La Salle Araneta University. Under the project, the main tasks at hand were the following for us. To dedicate an area where the fabricated reactor can be installed for phosphate recovery, and then process the septage and recover phosphates in batch operations, and application of recovered phosphate fertilizer to test crops in 2 cycles, particularly the dry and wet season here in the Philippines. So the fabricated reactor was installed at Salicneta Farm, as mentioned earlier, of De La Salle Araneta University, which is located at San Jose del Monte, Bulacan. So the main site, as you see, the one boxed in red, was chosen because of its proximity to the proposed crop test area, the field behind it, and the access road when transporting the collected septage. So the septage was processed in 100 liters per batch, and images presented below was also shown by Dr. Arnel a while ago, shows the hydrolysis precipitation at the reactor hot, followed by the varying drying state of recovered phosphate after precipitation process. So all the wastewater were all temporarily stored in drums. So here are sample pictures of the varying drying stages of the recovered phosphate. And as you can see, the dried precipitate is in powdered form. So for the testing, we had to produce around 8,687 grams to meet the amounts needed for the test crops. So the amounts are presented in the table. And 4 test crops were used for the project, namely tomato, eggplant, and 2 brassicas, the pechay, and mustard. So all presented in the pictures before you. So since the movement was very limited during the time, the team had to work hand in hand, and from the land preparation to seedling production to crop establishment and especially crop management. So here are pictures of the seedlings that we used for the testing of the crops. And here is the experimental area, the dedicated field and greenhouse areas that are located behind the reactor hut as the crop testing site. So you can see that we had the field and the greenhouse testing done for the fertilizer trial. So the following tables will now present yield performance of the different test crops. So for tomato, the table shows that the highest yield was obtained from the plants that received the commercial fertilizer, followed by the plants, fertilized with recovered phosphate. So the table also shows that the lowest yield was obtained from plants with no fertilizer application. The same trend was observed for the eggplant. Highest yield was still obtained from plants fertilized with commercial fertilizer or the T1, followed by T3, where it is a combination of commercial fertilizer and recovered phosphate, and then followed by T2 or plants that were fertilized with recovered phosphate alone. And the lowest yield was still obtained from plants with no fertilizer application. So for the pechay and the mustard, the highest yield was still obtained from commercial fertilizer, followed by treatment 2, fertilized with recovered phosphate, and the lowest yield was obtained at plots that had no fertilizer application. So we have submitted soil samples and plant tissue for analysis, and we are waiting for the results. So currently, we're also processing the second cycle data. Based from the initial results, commercial fertilizer obtained the highest yield. The experiment also showed that the crops responded to the applied recovered phosphate that gave yields higher compared to the crops with no fertilizer application. So the pictures that you see before you are actual harvests from the test sites grown with recovered phosphates. As you can see, harvestable products show promising results, and the recovered phosphate have the potential to grow crops that meet market standards. So what were the challenges while we were doing the experiment? So from the pumping of the septage, so the presence of debris affected the pumping that sometimes led to manual harvesting. The application of recovered phosphate, because it's in powdered form, so usually sometimes it sticks to the hand, and so we had to use sometimes spoon to make sure that everything was applied to the crops. And then the drying, since we had to dry it, the weather conditions affected it. So we had a time where it was almost raining the whole week, so drying was really delayed. So this is all for work package 3 under the project Necessities. So this is our team from Salicneta, which Doc Arnel has already presented a while ago. And so thank you. And I hope to hear, I'm welcome to answer questions later. So that's all from De La Salle Araneta.
Thank you so much for that, Apple. So I suppose the next speaker would be Amy. So if you have any questions, please feel free to type in the chat box and we'll get to them at the end of the talk.
Let me just share my screen. Okay, so good evening, good morning, and good afternoon, wherever you are on the planet. This is Amy Lecciones. I'm from the Society for the Conservation of Philippine Wetlands. We are an environmental organization, and our mission is to employ CIPA, or communication, capacity building, education, participation, and awareness so that people can take action for the wise use and conservation of wetlands. So the outline of my presentation goes like this. I will just say very few words for the work package 4 that we are assigned to do. Then, of course, we proceed to stakeholder engagements that we are doing, the challenges that we face, and the opportunities likewise, and at the end, some learnings and some next steps. So work package 4 is tasked with drafting of training materials, contacting a farmer association and NGO training, doing training sessions and contacting farmer associations and NGOs, dissemination through technical and media engagement, social impact monitoring, and stakeholder engagement. The activities embedded in work package 4 are particularly key to the success of the theory of change of this project. The work package 4 includes visits and exchange of professionals, focused training and strategic dissemination for the use of local and international media platforms beyond conventional modes of dissemination such as academic journals and conferences. Usually, it's not very usual that research studies have communication components. So we are very grateful for the De La Salle team for inviting us to join them in this project. So very briefly, what is a stakeholder? So we just say here that a stakeholder is any person or entity that has interest in your business or your project. And for the Necessities project, our key stakeholders have been identified as the farmers or the agricultural sector, the water sector, academia and other research institutions where their interest and probably to build on the research that is currently being done, and other relevant government agencies and offices. So why is there a need for stakeholder engagement? It's very important because you get to connect with your identified stakeholders, and it somehow ensures the sustainability of your project even after funding is done. And the development of training materials and stakeholders and media engagement strategies can also help achieve the long-term impact of the project. Of course, we all know that stakeholder engagement, just engaging with them already raises their awareness about what you are doing about the project. And this can also lead to the development of new partnerships and opportunities, and most importantly, to gauge the acceptability of the project by your stakeholders. So for this project, we have 3 major categories for our stakeholder engagement. The first one is to design and disseminate communication materials and conduct of SIPA activities. And then the conduct of training and other capacity building activities, and stakeholder engagement, and at the same time doing social impact assessment. These are the communication materials that we have developed. We have actually a website. It's necessities.org. You can see here our landing video and our main landing page. We have news and blogs in the website, and also infographics, so that anybody who visits the website will have an idea of what the project is and where it is, its activities, and where it is the activities that we are actually implementing. We also produced 3 videos. It is currently on our YouTube platform. We have very modest views, about 500 views as of now, but we are very happy with it. We think that's already a very good accomplishment. We also have an FB page. We, of course, as part of our social media platform, we have 478 followers as of now and 506 page likes. We also have a Twitter account, a LinkedIn account, and of course, IG. So if you would like to know more about us, and even after the project is done, we will still be maintaining this. So if you would like to know the developments in this project, you can just visit our social media platforms. Okay, so these are our videos that we produced. The videos that we produced were played at research conferences and other fora. Of course, this tells the story of the project, the process, the challenges that we faced, and everything about the whole process from conceptualization up to the testing of the fertilizer that the Saligneta farm had been doing. We also have these video explainers. This is where we have a very short videos explaining very technical terms like what is TrueBite. Paki-explain. So this had been a very successful communication strategy. We're getting a lot of good reviews for this. And of course, we were featured in 3 different webinars in the course of the project. We also took part in the virtual forum on the Philippine sector reform agenda. This is where the Department of Water, the bill that is proposed right now, was discussed. So the Necessities was part of that. And for the training for farmers, we had, originally we planned a face-to-face training, of course, but due to the limitations of the pandemic, we had to resort to virtual training. So we had a virtual training for farmers on October 14. And here you can see that we have 10 members of the New Mariang Sinukuan Farmers Association from Arayat, Pampanga, and also another 10 from Victoria, Laguna. And these are the farmers that participated in that virtual training. In that virtual training, we explained how fertilizer is derived from the septage and its application. And Miss Apple was able to show them that actually it is also a very good kind of fertilizer, and the farmers were very excited about it. So let me just play here a statement from, but this is in Filipino language, but let me just play what our farmers said about their learnings in the...
Magandang araw po. Ako ay si Roel Nuco, Pangulo ng Numerous Nukuan Upland Farmers Association of Arayat. Sa aking pagdalaw sa virtual training ng Necessities project para sa mga magsasaka, aming nalaman na posible palang maka-recover at makagawa ng steroid fertilizer o pataba mula sa dumi ng tao. Nalaman din namin na naging epektibo at ang pataba na ito, ang steroid fertilizer, sa mga gulay kagaya ng kamatis, talong, pechay. Ayon sa naging pag-aaral ng mga eksperto, nais ko at ang aking mga kasamaan na masubukan ang ganitong natibong pataba para sa aming mga pananim. At malaking tulong ito sa amin upang mabawasan ang aming gastusin pagbili ng pataba. At nakatulong din ito sa pangangalaga at pangprotekta ng aming katubigan at kapaligiran. Upang maging matagumpay ang aming inisyatibo, kailangan din namin ng suporta mula sa mga eksperto at pondo na maaaring magmula sa mga lokal na pamahalaan o pribadong sektor upang matulungan ang aming pagsasaka sa pagtatanim at pangalagaan ang kalikasan. Maraming salamat po sa pag-aaral ng Necessities project. Maganda.
Okay, so that was the president of the New Mariang Sinukuan Upland Farmers. They are very excited to actually try the struvite fertilizer. And these are the results. We had an FGD with the farmers, a focus group discussion, and we found out that both farmer groups were very willing to try the struvite fertilizer, and because they were saying that aside from the benefits from the environment, it might be able to reduce their farm production, cost of farm production. But at that point, they did not know yet how much it will cost it to recover the struvite. They were asking if they will be the ones to recover it. So because when we showed them how it is being recovered. Actually, they got a little worried because they said, oh, it might be difficult for us to be the ones to process it. But anyway, the main concern of the farmer groups was that if they will be the ones producing the struvite, is it safe for people's health? They were worried about, extracting the septage from the septic tanks. Yeah, and all those things. But in general, the perceived acceptability was due to the trust of farmers that the scientists and experts um, that conducted the research, as well as the awareness that they acquired during the training. Their questions were answered by the technical team, and so in the end, they were willing to try it, and they were just worried about the cost. And so after that, we also had a virtual training session with the LGUs, and that's the local government units and local institutions, and also the academic and research institutions. This was in October 29. And then on November 12, we had a virtual forum which was attended by the LGUs, local government, and representatives from the water sector, including the water concessionaires. So these are the insights from the stakeholders that we got during our interaction with them. The willingness of local and international stakeholders to collaborate. Just a minute. To collaborate and do a pilot scale technology and test the recovered phosphate was also indicated during our discussions with them. And we think that as more scientists believe in this kind of project, more stakeholders will be convinced, and hopefully there should be more buy-in from the LGUs as well, particularly the water districts. And based on the results of the recovered phosphate fertilizer, application of the recovered phosphate, the application of this recovered phosphate, it can benefit the farmers, but it still needs further research on the microbiological aspects and commercial viability. And they were saying that if next cities are willing to share the ideas for free, then they can try a pilot scale as well and consider appropriate plants or vegetation in specific sites. Well, somebody from the agricultural sector mentioned that it will be an added value to them, and since they are looking for ways to improve productivity of farmers and add value to available resources, including wastewater, and also to improve health and sanitation in our areas. These are comments from national government agencies and also from LGUs. Okay, so if cost and quantity can be competitive with those that are commercially available and sanitary parameters are considered, then they think that they are all willing to try this fertilizer. Okay, so one water concessionaire said that they can be the source of domestic wastewater or septage for the production of or recovery of fertilizer in the future. So they are willing to contribute to future activities related to this project. And also from the Department of Environment and Natural Resources, they're saying that our organization can help your research by promoting them to their stakeholders. And on social acceptability, there is still a need to conduct more studies on this aspect. Luckily or happily, on funding, PSHERD and CIRCA, PSHERD is a Department of Science and Technology Agency, and CIRCA, this is the Southeast Asia Regional Center for Agriculture, encouraged the project team to check out their grant facilities. So they are interested in actually funding the continuity of this project. So, however, in the more than 1 year of implementing the project, we encountered, of course, some challenges, and primarily this is due to the pandemic, which limited face-to-face interactions and trainings. So because of this, the training sessions were actually pushed back several times, and the testing of recovered phosphate by the farmers was also delayed. In fact, we are still trying to see if we can still proceed with that testing on the ground by our farmers in Araya and also in Victoria. Also, we were not able to do a survey by consumers on the acceptability of the fertilizer. For example, if it is being used in these crops, would they be willing to buy it and eat it? We were not able to do that because of the difficulty in doing actual interviews outside. But there were also a lot of opportunities since all activities were done online. So it was easier actually to partner with other organizations that are not based in Manila. We were able to reach more people even outside of the country. And we were able to maximize contacting the wetland communities and farmer networks. And they were able to join us in our virtual training sessions. And yeah, we were able to also reach out to other organizations and SUCs outside of the country. And there were several pitches for research collaboration among partners. And those that joined us, some are still communicating, I think, with our partners here. And some of the LGU participants actually, or the environmental management practitioners, including national government agencies and private water utilities, mentioned that they would want to see or test the viability of this technology and are willing to partner with the project. And also with the stringent nitrate and phosphate regulation in the effluent, and the Necessities project is or can be seen as a solution in the environmental and water quality management challenges. So here are some learnings from what has transpired so far in the project as far as we are concerned in the communication and stakeholder engagement. It is important to identify all relevant stakeholders of the project and reach out to them, because it is a key factor to the sustainability of the project. And we believe that buy-in from stakeholders, identification and testing of business models will make the project more sustainable. And finally, communication, education, awareness raising, and training. For example, like the Necessities Forum, we're successful in sharing the learnings and benefits from the project, also in soliciting insights and inputs on how to improve the technology, and in generating interest among stakeholders for possible partnership, which would target sanitation, SDG 6.1, and the reduction of water pollution in the Philippines, as well as in neighboring countries, while contributing to food security through fertilizer recovery. So with that, we are very proud to share that aside from this March of 2021, the Project Necessities received the Lima Award, Lima Water's Agos ng Pag-asa Award at the World Water Day awarding ceremony in March of this year. And just yesterday, it bagged the second place at the first Philippine Water Challenge in December, yesterday, which Apple represented. You can see here the photo of apple on the right-hand side of the PowerPoint. And so this is the communication and stakeholder engagement team. So thank you for your attention.
So thank you very much for that. So thank you so much for the team. And so I'll be bringing in the entire team, and I'll be spotlighting you so that we can respond to the different questions already in the chat box. So just give me a few minutes just so I can highlight everyone into the panel. Right. Yeah, because Apple, if you would want to open your video, yes, so that I can add you in the spotlight. Okay, so I think we have everyone now. So there are some questions in the chat. I'm sure you've seen some of them, but let me start with a question sent by Dr. Kibenko, which was actually sent privately. So the question is, it's being addressed to Mike. So thank you so much for an interesting and very informative presentation. My question is, are relevant government agencies and LGUs aware of your research findings and proposals, which they can implement to further propagate and strengthen sustainability in our country? Yes,
Thank you for that. Thank you for that question, Ma'am Benko. So actually, this is part of the work packages that we have in Necessities. The work package 4 is trying to engage a wider stakeholder audience, and in this case, that's why Ms. Ami Liciones is and her team is actually working on this as well. So yeah, the answer is yes, we are doing, and of course, no, it's still work in progress. As you can see that because of the pandemic, we still have limited engagement, but I think looking at the brighter side, in spite of this pandemic, we're still engaging this wider stakeholders. Yes, we are trying to inform them, and that's why we have this stakeholder engagement. Maybe Ms. Ami could elaborate this further if you want.
Yes, Ms. Ami, do you have anything to add?
Yes. In fact, in our three consultations that we had, well, they were not actually just consultations; they were like fora. We had the Department of Environment and Natural Resources, we had the OST, we had NEDA, we had almost all of the relevant government agencies concerned with agriculture and water. We even have the Fertilizer and Pesticide Authority, the Bureau of Soils and Water Management, almost all of the government agencies, we had them on board. Yeah.
Okay, thank you so much for that. The next question comes from Emerson Torres. So how can we guarantee the sustainability of the proposed wastewater system since it uses raw materials and energy too? Have you compared its advantage over the traditional composting? Who would want to take that question?
So I think
Doc Mike, go.
Maybe I will start with the high-level answers, and maybe the details could provide by my teammates. This it's like I'm a coach passing and assisting the ball to make this shoot for a three-pointer. No, anyway, that's a very good question. Of course, the issue of sustainability will always be an issue, and it will never be resolved by any one technology or one proposed solution. And in this case, there will always be a trade-off. There's no free lunch in real life. No. Is there a free lunch? I don't know, but most of the time I think there's no free lunch. So there will always be a trade-off. And in this case, the idea of sustainability is how we can optimize the system in such a way we can address these trade-offs. And I think through this project, as I mentioned, it's a work in progress. As a researcher, we always have this kind of questions, and we always generate more questions than answers, and that's actually what we are doing. So at first, we 2 or 3 years ago, we was funded by PSHARE DOST. We did first a desktop study to look at the big picture, the systems analysis approach, and that's why we do life cycle analysis. I believe I can call a friend so that I can introduce her as well. Is Miss Carla, is Engineer Carla Pausta here? Maybe he can share. She can share about the results from her master's thesis, because this is one way to look at this sustainability issue by looking at holistically. Carla, can you share some insights based from your previous study on the trade-off? For example, of course, the eutrophication, the greenhouse gas warming potential, and so on.
Yeah, Carla, you're still on mute.
So right now, Carla, while she's unmuting, she's right now at the laboratory at University of Surrey doing some analysis, I believe. And yeah, so Carla, you ready?
Yeah. Can you hear me? Can you hear me?
Yes, we can hear you now.
Yeah, because I'm currently at the lab. So yeah, I'm Carla, and I'm one of the graduate students involved with Necessities from the start. So yeah, so actually, like in terms of sustainability, we have started dealing or studying about the environmental impacts at first. So we did life cycle assessment. So one of the first motivations of this project is because of the changes in government regulations wherein wastewater treatment facilities would need to integrate nutrient removal in their systems. However, since we would like to propose a proactive solution, so we would like to study if we would also integrate nutrient recovery, not just nutrient removal. So based on our LCA, so just like the gist of the results. So of course, integration of nutrient removal would avoid more eutrophication, well as the nutrient recovery system. So this both produce good environmental benefits. However, one of the trade-off is increase of global warming potential due to the added energy requirement. However, it is not that significant because wastewater treatment plants are really required to integrate nutrient removal. But then, if we also integrate nutrient recovery, so it would also be beneficial for economics because we will produce a valuable product like fertilizer from it. So this is like the first step into analyzing its sustainability. Since sustainability would definitely include economic and social. So right now, in my PhD, I'm now studying the life cycle sustainability assessment of integrating nutrient recovery systems in communities, and how would it impact like bigger water resources, for example, the lake, Laguna Lake. So yeah, so I will integrate now social studies and economic studies with it.
Okay.
So, yeah.
Thank you so much for that, Carla. Before I call on the other members, maybe we can move on to the next question. It is still somehow related, and so maybe the others can address this one. The next question also comes from Emerson about the sustainability of the phosphorus fertilizer production. So he's wondering how much fertilizer would a typical household with 5 people produce? Will the amount of fertilizer sustain the nutrient requirements of a certain crop? For example, 100 square meters of crops. So maybe Arnel or Apple would like to take a shot at the question.
Apple, can I give you first the ladies first, or me? Okay, basically for the sustainability in terms of utilization of septage or sewage waste as a resource for material is that we will not be too much dependent on the fertilizer rich or the phosphorus rich country from for the production of fertilizer. Another thing is that when we do recovery of phosphorus from our water or wastewater system, this could also improve the environmental impact of the wastewater and the sanitation system. For the typical production of fertilizer per household, let me check with Albert. Are you here? I think.
Let me check if, yeah, Albert is here. Okay, I will add him to the spotlight again.
Yeah. So Albert is our research assistant. He's one of our doing the legwork, and that's why without this kind of people, this kind of price is not possible. That's why they are greatly appreciated here. Albert,
Okay,
can
Albert?
you unmute yourself? Or maybe you can turn on your camera so that they can see you.
Yes, hello. Good evening. So basically, for the um, amount of precipitate that will be produced, so considering the same property of the domestic waste generation, so at 600 liters of waste generation per day per household of 5, so we can estimate that we can produce about 1.75 kilograms of precipitate per household per day.
On the requirement of fertilizer, Apple.
For the amount of fertilizer that is needed for like 100 square meters, am I right? Was that the question? 100 square meters. That would be enough. Actually, one kilogram. Because imagine, like for example, for rice, you only need like one and a half bags of urea, for example, for urea during one application. During application for at a particular crop stage of rice. So like 1 hectare is 10,000 square meters. So based on what Albert has shared, in terms of the volume produced for about 600 liters, am I right, Albert? Yeah, more than one kilogram can be produced, and that will be enough to sustain 100 square meters, 100 square meter of area to grow crops.
Thank you. Thank you, Apple. And pertaining to the composting comparison, actually the challenge in composting is that I'm not sure if it's readily acceptable in the Philippines to use human excreta as a source for fertilizer, as a compost, and apply it to our crop. Usually, we only utilize, as far as I remember, our animal manures from cattle and chicken, I think. But I'm not sure if we have a regulation on human excreta and other source of phosphorus as fertilizer for compost.
Okay, thank you very much for that, Apple and Arnel. So there's a very long question actually on the chat from Crispian Lau. Perhaps you can respond to those via chat box, or maybe you can also send to Crispian some of your inputs regarding his questions. But maybe we can take one of those questions. And I wanted to ask you about how does the project actually relate to maybe the current standards of our wastewater in the country. So how do you see this project relating to the current standards of wastewater discharge effluents?
I think
yeah,
I can answer that, Arnel, right? Okay.
Oh yeah. Okay. Actually, the current standard now that we have is for wastewater is on the Dow 2016-08, and there's an additional or adjustment just this year, the Dow 2021 I think 21 regulation, which is the updated guidelines for the disposal. And this still a challenge in terms of the technology that will be able to attain that capability of producing the effluent needed. However, some technology are already capable of doing that, especially the nutrient removal technology. And the challenge for this one is more on how do we manage the sludge, because most of the phosphorus is converted to the sludge of the wastewater treatment. And for the septage naman, usually the septic tank processing or the sludge is being deployed in landfill, as well as for the nutrient or the sludge from the wastewater treatment facility. And this changed also in the regulation, because a lot of things is happening in terms of the wastewater systems in the Philippines, because as of now we have a very little household that are connected in the wastewater treatment facility, and most of these households are in the urban urbanized area. But in semi-urban or to rural area, there's a challenge of putting a wastewater treatment facility and consolidate the wastewater. Okay, so
Thank you for
a lot of
there was a related question. You are also working with our water utility companies. Is that correct? I know you have some engagements with them.
Yeah, maybe I can elaborate this
Yes,
one.
please.
And in connection with Crispian Lau's comments and suggestions, I agree with him. No? Actually, it's actually a multi-pronged approach. So you are not only looking at developing technologies or improving the systems. We have to address this from different point of attack to the problem. And in this case, policy is one, aside from the social aspect. No? So in this case, I agree that we have to look at this one. And of course, changing the mindset is the high level approach first. Because even if we can optimize the process, have already this acceptable product, if the consumer or there is no way to incentivize this kind of system, it will not work and it will take time. No? Panahon lang ang makakapagsabi kung ito ay magiging profitable. So sabi ko nga sa inyo, no, as what I had mentioned earlier, no, when you look, imagine the future. No? Some would seem ridiculous, no, maybe ridiculously expensive or costly, but these are still useful ideas. We just need to find the right way at the right time at the right place to really push this kind of system. We are transforming the system. Sabi ko nga sa inyo, as what I had mentioned, yung ROSAS, no? The resource-oriented sanitation system. In this case, you are not just removing the nutrient, but trying to recover it. But it takes time, no? Because as you can see, there will be like policy legacies, no? And technology lacking, infrastructure lacking that we have to look at. So these are the things that we have to consider. But and I agree. Short answer, there are still things that we need to do, of course, and that's why it's an ongoing process.
Okay, so thank you very much. I'll just take in the last question. Sorry, I know there are so many other questions, but may I request the team to respond via chat for some questions that we're not able to discuss here. So I'll take the one from Martin. So what are the waste streams from your process? Are there still wastewater and solid wastes? And how much will this affect sewage waste disposal and save on water resources?
I think I will ask our wastewater engineer expert. We have Dr. Irene Orbisido. I would like to invite her if she's here, she's around, if the internet connection is good.
Yeah, she's here, but maybe she can just use the audio if she's
the
unable
audio,
to turn on the camera.
No problem.
Would you like to respond to the question?
Can you unmute Dr. Orbisido?
Okay, she wasn't co-host, that's why she couldn't unmute. Hold on.
Okay, thanks everyone, and really apologies for not being able to turn on my camera. Kanina pa talaga nawawala yung internet connection ko. As to the question of Dr. Calao, what waste streams from the process, since we are already talking about the sludge being processed, so we have still the solid waste and the wastewater as byproducts of the process, but these are minimal compared to managing the whole wastewater system. So if we are processing again the sludge and recover phosphorus from it, definitely we have a wastewater which is of high pH. So we could normally just neutralize that one and send it back. If it's integrated in, say, for example, a wastewater treatment plant, we can just merge or combine that wastewater stream into that the wastewater treatment plant. For the solid waste, we still have some, of course, solids byproduct, but then again, that could be considered, if not of high quality, compost. It's at the back of my mind. Soil, not fertilizer, or soil conditioner or something like that. No, so some low quality solids. So I hope that answers your question, Dr. Calao.
Hey, thank you so much. So thank you for everyone. Unfortunately, that's all the time we have for tonight. And you've seen that they actually have a website. So if you want to reach out to the proponents of the project, or if you want to get involved, or if you have a similar related study, please feel free to communicate with our experts. So thank you so much, everyone, for joining us in the last webinar for the year. I'll just be in touch again for our schedule next year. So enjoy the holidays and hope to see you all again next year. Thank you, guys.
Bye.
Thanks everyone for coming.
Thank you, everyone.